Okay, so what is pressure? What do you understand by the term pressure? Pressure.
Teacher me. Teacher.
Yes, put up your hand and I see. Put up your hand. I'm not seeing.
Teacher me, Fiona.
Okay, Fiona. Okay, Fiona. Yes. What do you understand by pressure?
Pressure is the force acting normally per unit area.
Is the force acting normally per unit area? She has said force. So there is force acting normally. If someone does not say normally, can say
perpendicular.
Perpendicularly per unit
Area.
Per unit area. So force, it is a force acting normally or perpendicularly per unit area. So it means that this force is normal to the area at which it is acting. So if this is the area at which the force is going to act, if this is the area, then the force that is acting must be normal at an angle of 90 degrees. So the force will always act perpendicularly to that area. So when the force acts on this area, it causes what we call the
pressure.
Another person can say that pressure is force acting normally. Mungulu Fiona, you remain muted. When you want to speak, you unmute.
Okay.
Yes. So it is the force acting normally. Someone can say it is the force acting normally or perpendicularly. Perpendicularly per unit area of 1 meter squared. In both cases, you'll be given the mark. But if you put this is more correct because you have specified the area of 1 meter squared. Now, what are the units of pressure? We know that now, if pressure is given by pressure is equal to force. What are the units of force? Nyapendi, what are the units of force?
Newtons.
Newtons, correct. So force, they are newtons. And what are the units of area?
Meters squared.
Meters squared. So we are dividing force by area. So it means that the unit the SI unit is, we can have it newtons per meters squared. So if someone does not say newtons per meter squared, if does not write it like this, can write it like that. Go together. Where you have studied indices, isn't it? Munguru Fiona, I'm about to remove you. Please stay muted. So you have studied indices.
Yes.
Munguru Fiona, I'm going to remove you. That is the last warning. if you can't remain muted. Mungulu Fiona, I'm going to remove you if you can't remain muted. That's the last warning. So the SI unit is newtons per meter squared, or someone can say pascals. Are we together? Pascals. Pascals is equivalent to newtons per meters squared. So it means that 1 pascal, that's how they write pascal. 1 pascal is equivalent to 1 newton per meters squared. So that is the SI unit. So the SI unit, newtons per meter squared, or pascals. Another person can say, what are other units? Other units of pressure. Other units of pressure are okay, let me ask now questions. Other units of pressure. Dollar, Irene, give me any other unit of pressure that you know apart from pascals. Who knows? Any other unit? Can put up the hand. Any other unit of pressure apart from pascals? Who knows? Any other unit of pressure? Okay. So we have what we call atmospheres. Atmospheres is also another unit. Atmospheres is also another unit of pressure. We have also what we call bars. What we call what? Bars. Bars is also another unit of pressure. Members, are we together? Because you have muted, I can't hear you. Okay. Those are some of the units of pressure. So now we are going to see what is a pascal. What do you understand by this term? A pascal, the SI unit of pressure. What do you understand by a pascal? A pascal. You don't have to define that. A pascal is the SI unit of pressure. No. When you say that, you'll be marked wrong. So a pascal, remember that a pascal is the SI unit of pressure. We know that. So that means that a pascal is a unit used to measure pressure, used in measuring pressure. So that means that a pascal comes all about by getting a force, and that force is exerting on an area. So the force must be of 1 Newton. That force of 1 Newton is being exerted on an area of 1 meter squared, of 1 square meter, 1 square meter. You can make summaries with this discussion that we are having, but you can copy the notes. If you want, you can copy the notes. This book is there on the website. You go under notes and you look for Ordinary Physics by Kent. You download the book and you have all the notes. So what is a pascal? A pascal is, this one is a pressure. It is a pressure when a force of 1 Newton acts on an area. Acts normally on an area of 1 meter, squared. So it is a pressure when a force of 1 Newton acts normally, that word is important, acts normally on an area of 1 meter squared. That is a pascal. It is a pascal. So in this case, that pascal, we consider that this pressure P will be equal to a force, but that force is of 1 Newton, and also divide by the area of 1 meter squared. So the pressure that you get here is what we call a pascal, and that pascal is the unit of pressure. So force of 1 Newton is acting normally on an area of 1 meter squared. All right. So pressure in solids. So let us look at pressure in solids. Now you have seen the formula. Which formula do we use to find pressure? The formula that is used to find pressure is given by pressure equals to force divided by area. That's the formula of pressure. Force divided by area. Then you know that the units, or the SI units, they are pascals. PA, pascals. Those are the units of pressure. Are we together? This is capital P, A, pascals, because pascal is the name of someone. So pascals, PA, capital P and A, because pascal is the name of a human being. All right. Now let us look at pressure in solids. Pressure in what? Pressure in solids. Pressure in solids. Pressure in solids. Now, pressure in solids depends on 2 factors. Pressure in solids depends on 2 factors. Before we go to pressure in solids, have you ever heard people talking about pressure that this one has pressure? I'm asking you to unmute members so that we can first. Have you ever heard people saying this one has pressure?
Yes, teacher.
What comes to your mind? You say it is a disease?
A disease
In your mind,
which kills.
does it come that it's a disease?
Yes. Yes.
Yes, it comes like a disease. Some people will say like that.
Okay, so what causes it? What causes that disease? What brings about that disease?
I take a lot of sugar.
Some might think stress, depression. Stress even.
Stress. Having a lot of things to do.
Yes.
So stress, having sometimes depression. Sometimes, what about overexcitement? Can someone get pressure because of overexcitement?
Yes, teacher.
Possible.
Yes.
So it means that
like when someone is going to tell you something new, then you get somehow scared. So if I feel like the pressure, you want to know what is it. After telling you get excited.
Okay. When someone receives something new that has not been expecting, maybe it's a surprise. And you get that kind of pressure. So can you get pressure if someone surprises you right now?
Yes, you can.
Are you sure?
Not
yes.
everybody.
I thought pressure is for those old people.
No, even the young ones.
Even the young ones. But not all young ones, isn't it? Specific people. So it means that in their body system, there is some failure. So normally that one occurs when the heart is over pumping. The heart over pumps, and then it means that blood is going to move at a greater force. So blood will move with a greater force, and because the area of of the vessels where blood is moving is very small, so it means that the pressure is going to increase.
Increase.
So even in the body, there is pressure. There is that pressure that they talk about, but it comes due to the force at which the blood is moving. It moves very fast at a high speed, and then the area of the blood vessels is very small, so the pressure increases, and then someone maybe collapses. So pressure also in solids, we shall see that it has two kinds: the maximum pressure or the highest pressure, and also the minimum pressure or the lowest pressure. So pressure depends in solids, pressure depends on two factors. One, pressure depends on the magnitude, on the force that is applied. So magnitude of what? Magnitude of force. Magnitude of force applied. Magnitude of force applied. And two, pressure also depends on the cross-sectional area. Cross-sectional area. The cross-sectional area. So the cross-sectional area at which the force is being exerted, the cross-sectional area, because the force will be exerted on an area. That means that the force is in contact with a given area. So it means that the cross-sectional area in contact with the force, contact with the force, cross-sectional area in contact with the force. So those are the two factors, and we have seen that it is force and area. So the magnitude, but we say magnitude of force. We don't know the magnitude of force. Maybe it can be 100 newtons or 500 newtons. So that is magnitude. When I talk about 500 and 600, that is magnitude. So the magnitude of force and also the cross-sectional area. Now you have seen, excuse me, you have suppose someone, I know some of you are not of your body sizes, but you remember when you're still young, or before we had the lockdown, or when you are going somewhere and then people are packed in a taxi and they tell you, you sit on each other, and someone who's very slim is seated down, and then someone who's fat sits on that slim person. Do you know what will happen? Do you know what will happen? Someone who's very small has a small force. The weight is very small, but someone who's maybe fat, let me say like that, the force is very large. So if a large force is exerting on an area that is very small, we expect the pressure to increase, the pressure to increase. Let me give you another scenario. Yeah, you have seen nails, sharp nails. Are we together? Sharp nails. So the nail at the tip here, it has, what does it have? A large area or small area?
Small area.
So it has the smallest area here, smallest area. Suppose someone pierces you with this nail, it may cause a lot of pain to you, isn't it?
Yes, teacher.
Because its area is very small. It is very small, very small. So if the area is very small, and a certain amount of force is exerted or is applied on that nail towards your body, it means that you are going to experience a lot of pain when someone pricks you with that nail. In other words, the kind of pressure that will be exerted on your body will be the maximum pressure will be a maximum pressure. So this one will take us to the types or to the kinds of pressure that we have in solids. The maximum and minimum the maximum and minimum pressure. The maximum and minimum pressure. So the maximum pressure, let us start with the maximum pressure. Maximum pressure, part A, maximum pressure. How would you determine the maximum pressure? So for someone to determine the maximum pressure, you should know that this pressure occurs when the cross-sectional area is very small. So cross-sectional area is small. Are we together? Cross-sectional area is small, or we can say we have, or someone can say minimum area occurs when the area is minimum. The area is very small. This is what I was talking about. So here, in this scenario, which is here, we expect maximum pressure. Why? Because the area of this nail is very small. If someone pricks you with that nail, you are likely to experience a lot of pain, Why? Because the nail has a small area. But now, suppose it was a needle. Let me ask you, suppose it was a needle, very sharp. You know how a needle looks like? Huh? Suppose it was a needle and someone pricks you with this needle. Will the pressure reduce or it will increase? Unmute. Will it increase?
Increase.
It will increase.
It will increase.
Because now the needle, its area is very, very what? Very, very small. Very, very small. In fact, even the needle can enter into your body. Why? Because the needle has a very small area. So the pressure that will be exerted onto you is going to be a maximum pressure. So for us to obtain maximum pressure is obtained by getting the force that is being exerted divided by the minimum, this is minimum area. So someone can say pressure max is equal to force over area minimum, something like that. You can abbreviate it like that. So the maximum pressure is equal to the area, is equal to the force divided by this area here, but the area is minimum, or it is very small. So you should know that if you have max here, if you are looking at maximum pressure, then the area is minimum. Are we together? If you are finding maximum pressure, then the area is minimum. So that this is what is in they have tried to shorten this equation here by saying that P max is equal to F over A minimum, where A is the area. And then how would you determine the minimum pressure? So minimum pressure is obtained by getting the force then divide by the maximum, the maximum area. Okay. So someone can say P minimum is equal to force over area maximum, something like that. So if you're finding minimum pressure, it means that the area here has to be maximum. Let me give you one scenario where we have minimum pressure. Where we have minimum what? Pressure. Sometimes when you are walking in a congested place, or even at school here, someone can step on you with his or her shoes, isn't it? Someone can step on you with his or her shoes and steps on you. Suppose you are barefooted and someone steps on you with his or her shoes. So the area, the kind of pressure, you are going to feel pain, but you will not feel a lot of pain. Suppose there is another person who has these spiked shoes, like the ones they use for playing soccer, football, the ones that have spikes at the bottom. Do you know those shoes? Members, unmute.
Yes.
You know those shoes,
Yes.
the ones that have spikes. All of you unmute so that we can discuss this. So those shoes that have spikes, suppose someone steps on you with those shoes, what will happen?
Feel a lot of pain.
You feel a lot of what? A lot of
Pain.
yes, a lot of pain. So the shoes that have spikes on them, those shoes that have spikes on them, it means that those spikes have a small area. So it means that if they have a small area, they are going to exert maximum pressure onto you, isn't it? But if someone steps on you with flat shoes, and someone steps on you, so the flat shoes, these flat shoes, I may do for you pictures, I'm a good finance. So the flat shoes, for them, they have a large area. So here the area is large. So large area. But suppose let me leave because girls, some girls do not play football, but I know they have they have they have ever shown this kind of shoes. These shoes that have, they are called stiletto shoes. Shoes. These ones that have this behind part which is very sharp. If someone steps on you with this spike here, you feel a lot of pain, isn't it? Compared to someone who steps on you with this flat shoe. So the flat shoes here, for them, they have a large area at the bottom, but these stiletto shoes, for them, they have, this one has a small area. So that means that this one is going to exert a large pressure. I mean, it's going to exert a large pressure or a maximum pressure. Compared to this one that has a large area, and this one will exert a minimum pressure. So the pressure, the minimum pressure is normally seen in those objects that have a large area. A large area, a force is being exerted, but when the area is large, it means that the pressure that will be exerted, the pressure will be minimum, because the area is large. Are we together, members? These were just illustrations that you don't need to draw in your books, but they are just illustrations I try to explain for you. Any questions? Members, do you have any question?
No.
You don't have any question?
Yes.
Okay. Now, let me ask you, we are left with 2 minutes. Let me ask you this.
Teacher, I was asking.
Yes, yes, Farouk. Farouk? Yes, Farouk? You have no question. Okay, so this means that you have understood the maximum pressure and the minimum pressure. Is it so? So to make a small summary of what we have just studied about, so you should know that the force must always be in newtons. Are we together? The force must be in newtons. And number 2, the area must be in meters squared. So if you are given centimeters squared, convert it to meters squared. If you are given the force, suppose they give you in terms of kilograms, then you need to find the weight, and that weight will be in newtons. So that will be the force. So force in newtons and area in meters squared. And now we have seen that the maximum pressure is given by the force over the area that is minimum, and also the minimum pressure is given by the force over the area that is maximum. When we come back, we are going to start with this example and do the calculations. Okay. So when we come back, I'll give you a break of 2 minutes and then we come back.